Hello guys, welcome back to another one. Okay, let's move on to Doubly Linked List. But before that, let me tackle with you the bugs that I did not notice, or the edge cases, as they would call it in, let's say, coding problems, edge cases, wherein I forgot to have an if statement to check whether we are trying to remove the head or the tail. Example here, remove at a specific index. And if index equals 0, that means we're removing it at the head. And I did not notice that. And our implementation here will pretty much have the head stay the same way and also actually change the head's next value. So if I go back to our whiteboard, okay, so let's say we have a, oh, what happened to the thickness here? Okay, here we go. Let's say we have, why is it so thick? Try this one. Okay, there we go. Say we have A, too close, and then B, and then point to, oh, cool. C. What's happening to my whiteboard? Wait, is it the lag? Wait. Okay, okay. Try this again. A, point to, okay, I think it's the lag. B, and B points to C. Okay, so let's say we're trying to remove the zeroth index. So this is the zeroth index, the first item. And in our implementation, we are actually not checking whether this is the head or not. And the way we do this is that we will change the pointer of this item, which is the zeroth index, to the to wherever it's okay. So its next item here, A, is pointing to B. And in our implementation, the new pointer of A will now point to wherever B is pointing towards to. So instead of A will point to B, A's next will now be equal to C in our implementation. And in this case, we are actually trying to remove the head. We are not trying to remove letter B because letter A is the zeroth index of the list. Okay, so that is one of the edge cases that we had. Since our implementation works if we're not trying to remove the last item or the first item rather, which is the head. Because if we try to do this on letter B, okay, let's say B would be the first index. And then since on our implementation, we are trying to get the previous node before the item that we're trying to remove, that would be letter A. Okay? If you noticed, if I go grab my editor back, there we go. If you notice on the previous linked list node at method, we were actually reducing the index by 1. So let's say we're trying to access 1. 1 minus 1 is 0. And in this for loop, we're saying that we want to run this loop if I is less than index minus 1. 1 minus 1 is 0. And we are instantiating I to be 0 on the first loop. So 0 is not less than 0. That's why we are not going to run this, and we are returning the head because current node is that head, the current head, which would be letter A on the whiteboard. And now we're going to return that and go back to this and assign that to this current linked list node variable. And of course it exists, so we're going to skip this. And now we're going to do this operation wherein, if we go back to the whiteboard, wherein the next value of this A will now become letter C because that is what letter B is pointing at. And if we go back to our code, that is exactly what we have. As you can see over here, current linked node dot next, which is letter A, will now be, instead of letter B, become letter C. Since current linked node dot next is letter B, we will get letter B's pointer, or the pointer of current linked list node dot next, which is letter C. Excuse me. So that excuse me again. So that is what's happening here in our code. Okay? And in here, this is also the edge case for whenever we are trying to remove the tail. Alright? So example for the tail, if I go back to the whiteboard, if we're trying to remove the tail, for example in A, points to B, and points to C. So I'm just trying to redo this list again. Points to D. Okay? Let's just say we're trying to remove D, which is the fourth index. So, no, rather third, 0, 1, 2, 3. Okay? Letter D is the third index or the last item in the array. So then, based on our implementation, we will get C here. Okay? C, which will be with 2. And now we will change C's pointer to undefined, or to whatever D is pointing towards to. And in this case, it would be undefined. So let's say D is, how can I move stuff here? I can't move stuff in my whiteboard. Oh wait, I think. Oh, interesting. I can't move stuff. Maybe an arrow key? No. Okay then. Maybe I try to move this. Make it smaller. Okay, there we go. I can make it smaller. So let's say D would point towards um to null. Say null. Such good handwriting, bro. Anyway, so D is pointing to null or nothing. So now C will now point to null. But in our implementation, we're just saying that C will point to null, but our tail is still letter D. So that means D still exists in our list. Okay? So that was the edge case that we had in our code, wherein I did not take note of it yesterday. Excuse me. That's why if we change C to be equal to the new tail, D would not exist in the list anymore and would be considered garbage, and thus we will not see it anymore, or it's gone. It will be freed up in the memory or whatever. Okay? So if I go back here, that is exactly what we had as well. We're checking whether index is equals to this dot length minus 1, and the length would be 4 if we had A, B, C, and D. So A is 1, B is 2, C is 3, D 4, 4 items. But when accessing indices in JavaScript, or I think in any other programming language, yeah, when accessing indices or items in array, we will always access the first item with number 0. Bracket notation is what they call it. That's why we also have the same mechanism in our linked list. And in here, if index is equal to distant length minus 1, for example, in our implementation, the length of our list would be 4, so minus 1, that would be 3. That means if we're accessing the last index, we would be having 3 as our index parameter above. So now if it is equal to that, we will just change the tail to be equal to the previous linked list node. And I think I should have better variable names here, so I guess we can just say so. There we go. Okay. What happened? Possibly. Oh, okay. So, boom. There we. Oh, okay. There we go. space, 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 space. Okay. So just take note of that, as I also make mistakes. But goodness, this is still pretty fun to debug. But yeah, and I think there's nothing wrong with this anymore. I hope. Remove that, remove. Okay, and if you noticed, I am actually using TypeScript now, and because I set it up. And on the left is where the JavaScript implementation is, and I also did it the same way as I'm doing it on the TypeScript now, as you can see. All right, I forgot to add. Oh, never mind. I think it's here. Yeah. Okay. Good. And yeah, I think that is it. Wait, let me try to have the edge case wherein we will be removing um we will be removing this item right here. Let's see if we will remove if we will be able to remove the item, making the list undefined or no. So the log list. I haven't actually tried that yet, so let's try it out. Okay, run this code or run this file right here, linked list.ts, and see if it works. It's taking a while. Okay. We are not able to remove it successfully. Okay, another edge case that I have not foreseen. Cool. Ooh, okay. If the value is equals to item, if previous linked list node, aha, we are not doing it. Okay, so we have to have another edge case wherein if we only have a single item, if this dot length is equals to 1, this the tail is equals to undefined, and then this dot head is equals to undefined. Like so, and then we just want to return, and of course, this dot length would now be equals to 0. Okay, that's another edge case, and I think we should also have it in here, like so. Okay. Oh wait, I think this would still be the same, so we will throw an error if it's greater than 1, because we have a greater than 1, yeah, yeah. We're trying to remove at the index 1. Oh, greater than set length. I think should be greater than set length minus 1. Yeah, I think it should be index greater than or equal the set length. Just in here, we're checking if equals. Oh, okay, okay, okay. Okay, correct, correct. This is correct. Throw an error. Remove, remove. Okay, let's try this out again. And see that this should work now. Damn, a lot of edge cases. Wow, very cool. Okay, let's see now. This should work. Should have undefined as head and tail. And the length should be 0. Okay, run, run, run. Having tests is pretty nice actually at this point. Wait, let me actually have this as well on the JavaScript though. There we go. Very nice. JavaScript above. There we go. Okay. What else? What else do we have? We have What else can I think of that might get errors here? Remove. Okay. Remove that. Okay, let's try the remove that actually instead of remove. Remove at. Let's see if we get an error if we say remove the second item. In this case, we don't have a second item. Remove at the first index. Okay, which means the second item in this case. Let's see if this works or not. We should get an error. Let's see. Okay, there we go. We get an error. There we go. Cannot leave an item. Cannot remove an item past the length left. Current length is 1. And we don't actually need this because if the length is 1, that means we can only remove the 0th index. And if that's the case, okay. In here, we're just removing the head, but the tail would still exist. Okay, so our implementation above should work actually. Here we go. Okay, this should work now. If I say now, npm run test node, we have remove at 0. We should have undefined as for the tail and the head. We have no item in the list at all. 0 length. Okay, let's see if this works. Let's also do the same thing over to the JavaScript file. Let's see here. Okay. Okay, very nice. And I think that's it for the linked list. Hopefully. Of course, guys, if you noticed some bug, I do hope I will appreciate it if you tell me any bug that you noticed or inconsistencies with my implementation. Okay, let's proceed to the doubly linked list. Okay, I do hope that this is good now. Let me commit this real quick. Fix another bug for edge case single item. Okay, commit that. Oh, and right now for the implementation, we will be using TypeScript. So don't mind this file right here. Okay. After committing this, let's talk about doubly linked list. That took a while. All right. Okay. Let's talk about doubly linked list now. Just like linked list, doubly linked list is well a linked list, wherein each item in the list or array, we can call it, points to each other. Okay, from A will point to B, and B will point to item C. But in a doubly linked list, it is not only in one direction. It will also point backwards. So A points to B, and B will also point to A. Okay, if I just write this correctly real quick, A small arrow, B points to C, B points to A. There we go. And B points to C, and C also points to B. There we go. So we can think of it this way. There is from head to the tail, and there's another one which is from tail to the head. So C would be the tail in this example, and this would be the head, like so. Okay. So in this case, we can check about how we can let's say do some operations here. So let's say we have A, B, C, and D. Okay, we have A. Let me actually give some big spaces here in between. A points to B. Let's try to make the arrow longer. Points to B, and B points to A, and B will point to C, and C will point to B, Okay, let's move this a little bit more to the side. Okay, this is actually pretty kind of annoying. I shouldn't have centralized it, but anyway. And then C will point to D and D will point to C. And in this case, D would be the tail, okay? And A would be the head. Okay. Let's say we want to try to remove letter B. Okay, let's remove letter B. Remove, or I guess we can say RM. Okay, let's try to remove RM letter B. How can we do that? Well, just like in linked list, we need to change the pointers of the items in the list. So if A points to B, we need to point A to the item where B is pointing at. So we need A to point to C now, okay? And there's one more thing to worry about, and that would be where C is pointing at, because we want B to be gone, okay? We want B to have no references to it. We, or like in other words, we want the items in the list to not reference or to point towards letter B anymore, so that letter B would be gone from the list. So in this case, we need letter C, its previous item, to point towards wherever B is pointing towards previously, or whatever items B, whatever B's previous item is, okay? So that would be letter A. So now, in this case, B would be undefined. There's no item that is pointing towards B, so that means in the list, B would be gone. Okay? And if we try to remove now the head, so okay, so let's see we have, excuse me, we have A, again, okay, so make this real quick, C, let's say we try to remove A, okay? This is the head, and we try to remove it, RM, let's say, because RM is a shortcut for deleting directories, I think, yeah, in bash script, but anyway, that's not important. Let's say we want to remove A. So in this case, we need to make B the new head, and we just want to remove the pointer for B. So we'll just say this.head, this.h, I guess we can say, will be equals to this.head.next, and that would be letter B, okay? And then letter B, I guess we can say this.h.next or that previous, since now the head, since now the head is equals to letter B after this code execution here, you can say that this.h.prev would be undefined. Undefined, or you can say null in that case. No, like so. So now there's nothing pointing towards letter A, which was the previous head. So this is considered to be garbage and removed from the list. And this would be the same for the tail, but in this case it would be, okay, we say tail. Okay, let's just try to do it at a different list. So down below, trying to remove letter D from this list, let's say. B points to C, C points to B. Okay, let's remove yourself. C points to D and D points to C. Okay, let's try to remove tail with RM, let's say. Okay, so to remove tail, we just say this, that T, or tail, I guess we could say, the tail of this list, we want to change it to be equal to whatever item, to whatever is the tail's previous item. So this is the t dot previous or dot prev, we can say. And then now this dot t. So now that would change the tail to be equal to the tail's previous item. So now it would be equal to c in this case. So the c's dot next, okay, so this dot t dot text would be equals to null because we don't want to point toward d anymore. So now the new tail would be c, and c's next value would be undefined. Okay? And that's pretty much it for doubly linked list. Let's try to implement this while keeping in mind of the edge cases. I hope I can keep that in mind. So let's try it out if we can produce and try this on the first try. Okay? Alright. We have our code editor ready and set up. Let's uh let's get hacking. Let me just drink some water first. Excuse me. Okay. So first, since we're using TypeScript, I will also walk you through how we can, code in TypeScript. First, let's declare a type, or we can also declare an interface. Should we declare interface or type? You know what? Let's declare an interface since we're using objects here. Why not? Node, and then whatever item is passed in that node, like so. And of course, we're getting an error because, well, it is already taken globally. And I'm not sure how to configure my TypeScript, so I guess we can just say doubly linked list node. There we go, just to not have conflicting names for the types. And this here is what we call a generic function, wherein whatever is passed on in this letter T, we can now access it inside the types of this um interface. Let's say, for example, we have a key of value for this object. We can apply T there. Okay, so that means value will now have the value will now have the type of whatever is passed on in this node or in this object right here. Excuse me. Or rather, whatever is passed on in the value, for example, we pass on the string of hello, that means letter T here will now be equals to, well, a string, somewhere along those lines. Okay? And now we have previous type, or prev, which would be equals to, well, this interface, and we just pass on T. So that's why you can see the importance of using generic types here. You can reference it recursively. No, no, no. It's not called recursively, but there's a term for it. But yeah, just referring it to itself. And then we have null or undefined, which means this is optional. But it's a typo, so just type correctly. There we go. Let's go with next as well. So reference itself. As you can see, the autocomplete is working fabulously, which could save us some time. And there we go. That's pretty much it. And now we can say doubly linked list T. No, no, no. I think we don't need that. There you go. Just like so. Yeah, we don't need that. Okay, that's it. And now let's declare our data structure. First, we have the types. So what will we use inside this class? Well, we will use the head variable. So private means that this will not be accessible on a variable wherein this class is declared. This is only accessible inside the class itself. Okay, so let's try that out actually. We have const list equals to doubly linked new doubly linked list, and the classes are pretty much an object because it is why it's called OOP, object oriented programming. It leans towards using objects. Okay, but anyway, private is either doubly linked list OT or null or undefined. All right, I think that is why we need letter T here. There we go. Okay, then the tail as well is equals to doubly linked list empty or null or undefined. Okay, and should be node rest. Okay, now we have the constructor wherein we will create keys inside this object. And the first key, which I forgot, should be the length. I think they should be accessible publicly. So public pretty much means this can be accessed by the variable that calls this class. Okay, so you will see in a second. Okay, the public length is a number. This is for bookkeeping. Why are we getting an error here? Okay, there we go. And then this cut head is equals to undefined. Although this is unnecessary, I like to be explicit as much as possible as long as I'm not lazy. Okay. Ah, okay. So we really can't. That's interesting in TypeScript. This is a new I think it's a new one. That's cool. Okay, we can just say const double list, I guess. Excuse me. I need to search about how I can get around it in configurations. But anyway, now if we try to check, there we go. Only the length is accessible in the instill sense, of course, because we can still access the head if we want to. But of course, TypeScript will give us an error. So if you try this in JavaScript, you can definitely still access the head, if I'm not mistaken. Okay. So let's try to make the operations now. You know what? Let me actually change the length of book to public unsingles here. Because why not? There we go. So that it will pretty much be the same as an array in JavaScript, wherein we can get the length of the list. Okay. So first we have the append method. Okay, append, wherein we will take an item equals to letter T. It can be anything that we want because in here we're trying to throw out a node. Or in this case, since we're only appending, this will just be void. Okay? We're not going to return anything. It's a function that doesn't return anything to its previous address. It just returns nothing, a void, nothingness. Okay. But anyway, in here we just say this.length. So we should increment length by 1. So this one's just an explicit way to do it. You can also do something like this.length plus plus or this.length plus plus equals 1. Plus equals 1. You can do it this way. So this.length plus plus is only exclusive, if I'm not mistaken, in JavaScript. Okay. Anyway, I like to do it this way now after learning more about post increment and pre increment. But let's proceed. Where was I? Ah, first let's check if the head or the tail exists. So let's say if, or rather if it does not exist, okay? If this dot head is null, or in this case it's a short for negation, wherein if this dot head does not exist, this will be equal to true inside the if statement. That means this will run, or the code block inside the if statement will run. Okay, so if the head is undefined, that means it's going to run this code below. Okay, so we can just say this dot head is equals to item, this dot tail is equals to item, like so. I forgot, it should be a node. Okay, so const node is equals to value item, and this one would satisfy the doubly linked list node T. So is it not satisfied? Oh, okay. As you know what? Let me make another one before. Private generate doubly linked list node. Okay, that will be the item T. This returns. So this is what we call we're going to be explicit on what this function returns. So we're going to specify the types. And in this case, we're going to return the doubly linked list node with a generic, or it can also, oh yeah, we're only going to return this. There we go. Then we're just going to return an object wherein value would be equals to item. Next would be equals to undefined. Previous would be equals to undefined as well. Like so. There we go. Okay. So we'll just say this generate doubly linked functions node item. There we go. So now we're going to assign head to be equals to the node that we just created and tail to be equal to the node that we just created. And we're going to return because we don't want to do the operations below. Okay. So now, what if the head exists in this case? Well, we'll just say, excuse me, we'll just say that this, the tail, the next would be equals to node. Alright, in this case, we should be checking for the tail because we're appending to the list. Okay? So we are adding an item or a node at the end of the list, like so. And of course, node, node.previous is equals to this dot tail. And now after that, we will just make the tail to be equals to the node, like so. So in here we're saying, okay, get the current tail of the list and assign its next value equals to the node that we just created. And then get the previous or rather assign or rather point the current tail to be equals to the previous item of the node. So it will look like exactly like we have let me grab the whiteboard. Exactly as we have over here. Why is my cursor not seen? As you can see, it's like a ghost. Okay, anyway, it's pretty much the same as this one over here. Okay, wherein we're saying that, oh no, this one is removing, so let's actually let me actually show it to you right now. B, C, D, and I should show you the backward thingy as well. Backward. Okay, so let's say we're trying to add an item here. Say append E. Okay, let me just write that in a more spacious way. We're going to add E. Okay, so this is the current tail, and then we're going to add E now. So we'll say that D will point to E first. Okay, so we'll create a link from D to E, from the tail to letter E. And after that, we're going to create a link from E to letter D. That means E's previous item would be letter D here. And then now, at the end of the operation, we're just going to assign tail to be equals to letter E now. And this will not be equal to the tail now. Instead, tail will now be letter E. So that's what we're doing in the code that we have over here. Okay? Excuse me. So let's do the same way with the prepend, but in this case, it would be the head. Okay? Item T, void, return nothing. Then we'll just say this dot length is equal to this dot length is 1. Excuse me. Then const node is equals to this dot generate node item. And since we're going to prepend and we will change the head at this point, we'll just say if the head does not exist yet, then we're just going to do the same operation that we did before. then return like so. And then just like in tail, we will do this that head dot previous in this case now, because the head, if we go back to the whiteboard, so let's say we have a new one, a new list. So B points to A, B points to C points to B, C points to D points to C. Okay, let's say this is the head. How can I move this again? Oh goodness me. Maybe I can zoom this in to the max. Move it like this. There we go. Okay, let's say we want to add, okay, A is head. We want to add letter Z here. Okay, add Z. So we'll say that A's previous, or the head's previous node would be equals to letter Z. Okay, so that's what we're doing in the code. And then Z's next item would be equals to letter A. And just like before, we just assign head to be equals to Z now at the end of the operation. Okay, so let's do that right now. Okay, move the code here. There we go. So say this dot head the prev is equals to node, and node that next is equals to this dot head, and then this dot head will now be the equals to the node. And that's it. So let's see if this works or not before we proceed to, you know, do some stuff, do some removing and stuff. So we'll just say append 1, and we'll say append 2, and then append 3. Let's see if the appending works. So we'll just say console.log doubly list. So say npm run ts node doubly linked list, copy that, and then run the code. Oh, doubly linked list. Okay, wait. Okay. I mistyped. So, double, but doubly. Okay, doubly. Okay, there we go. Run that again. Wait for it to run. Okay, very nice. As you can see, it's circular. That means it's pointing to its previous value, and its previous value is pointing to itself. That's why it's getting circular here. Here. Anyway, we have the first item, which is the head. That would be 1. Very nice. And the next item would be 2. And then 2 will point to 3 right here, which is the tail. And tail, next, it will point to undefined. And previous would point to 2, which it should be. And then 2 will point to 3. Right here. Okay? Here. As you can see, it's pointed to 3. Okay. And let's try to say doubly linked dot prepend 100. And now our head should now be equals to 100 over here. Okay? Let's see if that works or not. Okay. Our head should be equals to 100, and the second item should be 1 here. Okay, there we go. As you can see, the value for the head is 100, and its next node is equals to this here, wherein this next node's value is equals to 1, and 1 will point to 2, and then it will previously point to this head right here, 100, and it's in circular motion. That's why it's saying circular here once again. And yeah, go so on and so forth. Okay, so let's try to implement the get and then get item at specific index methods. So the first one would be get item. Which item do we want to get? Okay, and we'll return the type of doubly linked list node t, or we can also return undefined or null, because we might not find the item in the list. This item might not exist in the list. So we're just going to, just like in doubly linked list, we're going to loop through the items. And the special thing here is that we can loop from the tail to the head. Unlike in linked list, wherein we can only loop from the head to the tail. So we can do this in whatever way we want, either in ascending order or in descending order. But in this case, we're just going to do it in descending or in from head to tail. Okay. You can do this from tail to head. It's a doubly linked list, but we're just going to do this from head to tail. Okay. For let index equals 0 as long as current node exists, and index is less than this dot length plus index. Okay, that's why bookkeeping is important. And if current node dot value is equals to the item we are looking for, then we just break out of this loop. Then current node is equals to current node dot next. Then if current node does not exist, return undefined, or we can just say return current node overall. Okay, there we go. Beautiful. So now let's do the get item at index. Okay. Get item at, so whatever index. There we go. This will return the same thing. Null or undefined. So then I'm just going to do another loop. What's this dot head? But in this case, alright, we need to also check if we're going over bounds, you know. So if index is greater than this dot length, okay, you can just throw a new error wherein cannot look for an item that is past the cannot look for an item in index on index plus index. So let's pass the lists lists length -1. So there we go. What are we getting an error here? A plus. Okay. There we go. Excuse me. And current length b plus this dot length. There we go. Okay, so now let's do the operation here. For let I equals 0 as long as current node exists and I is less than index -1, just like earlier in the linked list. We just add I by 1 or increment I by 1. So now current node is equals to current node dot next. Excuse me. Okay, so now we're just going to return current node. Okay, let's try this operation now. Let's try to get the first item, okay, which is supposed to be 100 when we prepend. Try to run this. Okay, copy everything. There we go. Run that. Okay, I just turned on my noise suppression. Excuse me if it got noisy for a bit. Anyway, there we go. As you can see, we got the value of 100. Okay, very nice. And of course, it's pointing toward 1 and so on and so forth. You can also get the value if we want, but in this case, we're just returning the object itself, or the node in this case. Okay, so let's try. How about if we go, say the length of this is 4, let's try to go 4. Okay, this should be if index is greater than or equal. Okay. Okay, what if we actually try this? It should return undefined. This should return to us undefined. It returned to us 3. Oh. It should return undefined. 1, 2, 3, 4. Huh. Is it because I need to have this at -2? But I thought -1 was working. Let's try. I mean, this one will definitely work now. Oh, no. Oh. 4 minus 1 is 3. Oh, okay. Makes sense. 4 minus 1 is 3. Okay. So it should be index only. Oh, okay. Makes sense. Oh, okay. The -1 that we implemented in our linked list is when we are looking for the previous node. If we check down here, there we go. The previous node of the specific index or item that is in this index. Okay. So if we say -1, that means in 4, we're looking for the node. We're looking for the node that is before the item that is in the specific index, which is the 4th index or the 5th item. Okay. So now this should work. Ooh. I should take a break, but let's continue anyway. So I'm getting used to this, which is very nice. I like it. But yeah, let's see if this works. It should work. Return to us undefined or null. There we go. It returned undefined. Whew. Very nice. Everything is working fine. Let's try to implement the remove or the removal of a node. Okay. Excuse me. Okay. Let's say remove an item P. Then we're just going to return that item. So, and then let current node equals this.head. Then for let I or index equals 0 as long as index or as long as current node exists and index is less than this.length plus index. There we go. If current node dot value is equals to the item we're looking for, we break out of this loop, and then current node is equals to current node. Excuse me. Okay. Okay, in here we'll check if this dot head is equals to current node. That means this is at the start, okay? Or that means we only have a single item. Or this dot tail is equals to, wait, is it tail? No, it's only head. Okay, it's only head. If we are at the head, then we will remove that head, okay? So that means we will unbind is that head that next, or that previous rather, would be undefined. Okay? Of course, we're going to return if we find nothing. If current node does not exist, return undefined, and there we go. So now the head will point to nothing. Oh, no. This that head that next that ref. Okay. Current node. Why would it be possibly now? Excuse me. Okay. So in here we're going to check if current node dot next. So this is another edge case where we only have a single item. If current node dot next does not exist, that means we only have a single item, so we're just going to remove that. Okay, we set head. So in this case, we're going to return the item, right? So we're just going to say this const temp equals to this dot head, and then this dot head will be equals to undefined, and this dot tail will be equals to undefined as well. Since we want to remove this item, which is only a singular item in the list, and then we just return them. Okay. So now, why is this still? I see. Should be inside. So. This dot. Can't we reuse this? I can't. I think we can't. Oh no. If this dot head at next is undefined. Yeah, we can reuse this. So now why is this happening? Well, we can just say question mark, I guess. There we go. And if this dot tail dot ref is undefined as well. Yeah, okay, good. So if we only have a single item, that means the head would be equals to that item, and the tail would also be equals to that item. So we just run this code below. Okay. Then in here, if we don't have a single item, that means the next for the head exists, there's an item right next to the head, and the previous item for the tail exists, that means there's an item before the tail. Okay, then we will just run the code below. We will not run this code here. Okay, so in here, if our current node is equals to the head, that means we're trying to remove the head in this sense. Okay, then we just say this dot head dot next dot priv will point to nowhere. Okay, so that means if I go back to our canvas or whiteboard Canva, okay, let's say that A points to B and B points to A, and that's a nice B, bro. B points to C and C points to B. Let's say we're trying to remove V here. Oh, right, no. We're trying to remove A, which is the head. Okay, head RM. Okay, so to remove A, we say that A's, and rather, since A is the next value or the head of this list, we just say that that head, so this head or the head of this list, okay, get its next value, and that would be letter B right here, and then get the previous value of the letter B, which is now B. Its previous node is A right here, it's pointing to A, and change that to be equal to this or to undefined. Okay, change that to undefined or null. So that means B is pointing to nowhere now. It's not pointing to A anymore. And then after that, if we change B to now be equals to the head, that means there's nothing that is referencing A in the list anymore, and it will then be considered to be garbage. Okay, so let's try that out. Let's grab the code here. Now I say this dot head is equals to this dot head dot next. Excuse me. Yeah. So let's do the same thing. Okay, let me just minus the length here. That's one. There. Let's do the same thing for the tail. If this the tail is equals to current node, let's say that this the tail that brief that next. So it's the other way around for the tail. Okay. So what is this doing? There we go. Okay. So we're just doing this almost the same way as the head, but it's the other way around. Okay. We're going to get the previous node of the tail and point the previous node's next node to be equals to undefined or null. So this previous node of the tail will not point to the tail anymore. Then we're just going to change the tail to be equals to this tail.ref. Okay. Okay, what else? I think we handled all the edge cases now. Okay. So we're trying to remove this, right? Yeah, okay. So just like in the head and the tail, we can say the current node. Okay, we want to return this as well actually. So return that. There we go. And this operation should be up here. There we go. Okay. Okay, that's it. Down here, say current node dot previous dot next would be equals to current node dot next. Okay. Why would this be considered undefined? Okay, we're just doing this to satisfy TypeScript. There we go. Okay. We're doing this to satisfy TypeScript because even if the item, since current node.prev will only be undefined if it is only a single item. Okay, and the same for current node.next. And of course, if it's a tail, then oh wait, no. It should be like here. It's undefined. That means it's the head. Okay, and over here, it's undefined. That means it's the tail. Okay, there we go. So this is just to satisfy TypeScript. Okay, this is pretty much the same logic. Wherein if the tail is equals to current node, that means the current node will be pointing to nothing, to undefined. It's pointing to nothing. Okay. So now in this case, we're just doing the same logic that we did for the head and the tail. We're in current node.prev, so the previous item. So if I go back to the whiteboard here, so say A points to B points to A, B points to C, and C points to A. Okay, we're trying to remove letter B here, RMB. Okay, so we're saying that current node.prev, let's get the previous node of this letter B, or the item that we're trying to remove, and then get the next value of this previous node, which is, well, it's pointing to B, and change that to be equals to letter C, the current node.next, and That's pretty much it. And let's try to run this, and of course, const okay. Turn current node. So okay, let's try it out. So let's say in this, we're trying to remove $100. So that means now 100 should be gone from the list. Okay. Try this out. Wow, it's been 1 hour. Okay. Oh wait, I haven't shown the code editor. Okay, there we go. Ooh la la. Oh, okay, let's see. So this is the first console log wherein we got the item 0, and this is the second console log wherein we console logged the list itself. Okay, it works. As you can see now that 100 is gone. So if we console log doubly list here instead of getting the item. So let me actually add a space in between. Excuse me. That was unsightly. Anyway. Let's see now what the result will be to make it more clear. There we go. As you can see here, we have a length of 4, and the first or the head is equals to 100, and it points to 1. And here, now 1 is equals to the head, and the length is now 3. Okay. So now let's try to implement the remove at, or remove at a specific index. So it's pretty much the same as get item at, but in here we are removing an item. And if you noticed, we actually have a repeating logic here. Right here, and up here. So what we can do is we can just have down below private get node at index, or is it index or item? Get node. Okay, no, it's item. Oh no, is it item? Yeah, it's item. Okay. Get item t. Then we're going to return a doubly linked list node p, or it might be null or undefined. Excuse me. Okay. So we can just copy paste this guy like so. There we go. Return current node. Go. Then are we getting an error? Ah, okay. Oh, okay. Get item node. Okay, and then in here we're just going to assign const, or rather let. Are we redeclaring it? Yeah, no. Okay. Const current node is equals to this dot the function of this class of get. Where is it? Dot get item node. Okay, there we go. Okay, and the same thing for the one above, which is get item, and we can just return whatever is returned by that function. There we go. Okay, very nice. Now let's try to implement the remove at function. Okay, so down here, remove at. I guess we can be symmetrical here. Below this. Okay. So below the remove at what index number. Then we just return a doubly linked list, node empty or null or defined. Okay, I'm lagging, but doesn't matter. Let's see here. Go. Then undefined. Okay. Let's copy paste the error here. And then I think it will pretty much be the same thing. Okay, let's try to implement this first and see if we will have the same for loop. Okay. So we're going to find the item. So head for I equals 0, I is less than, as long as current node exists. And I is less than index minus 1, I or plus plus I. Okay. See up here, is it the same? Yep, it is. Oh, no, it is not the same. It's not the same one here. Oh, get item at, oh, yeah, because this is less than, so it's automatically minus 1. Okay, good. So we don't need this. Okay. All right. Okay, so we are actually doing the same thing. So private get node or get item at index number. Yes, get item node at return doubly linked list node p or null or undefined. Here we go. And then over here, we just copy it. There we go. And then up here, we're just going to return index, like so. Okay, so in here, we just say const current node is equals to this dot get item node at specific index. And if current node does not exist, return undefined. Excuse me. Okay, and we're pretty much going to have the same logic here. This length is equals to this dot length minus 1. Okay. Yeah, it's going. I think it's the same logic. Is it? Remove. Yeah, it's the same logic here. If this dot head dot next does not exist, or this dot tail dot prep does not exist, let me actually change this to, just to make this more readable, is does item have single, or does list have single item? Does the list have a single item equals to list has a single item. If list has a single item, we do the code below. Okay. TypeScript, of course. Mamma mia. How can we do this? Be a ninja. Const item is list head equals to I guess we can just say question mark, you know. Of course. TypeScript, TypeScript, TypeScript. We can't do this, can we? Let's see here. Uh, Guess in here we can just have a still. Oh, what? It's just getting into nest and nest of. Mamma mia. What? Hmm. If this still exists, or what? But earlier it was working fine, so it's good. Still the same. Oh, okay. I guess that works. Alright. So what this means is that if this still exists and its previous item, or rather it's pointing to a previous node, then we run this. Although we know that it is true, but you know, TypeScript is TypeScript. But I guess in this way it's now more readable. So yeah. Anyway, okay, where were we? I got distracted there for a second. Oh yeah. Here. So it's the same logic. We're in. Let's try it actually. Since it will be the same logic, why don't we try to extract this and say that this is a private remove node, where we're just going to node okay. There we go. Okay. And then in here, we're just going to perform return remove node current. Okay? We're going to return whatever is returned by this operation right here. Or by this function. Alright? So we can reuse this now. This dot remove node current. Okay? There we go. And now, let's try to run this function. But first, let's format our code and then test it out. Okay? Okay, very nice. As you can see, it's formatted nicely. Okay. So in here, let's see if it still works. npm run es node doubly linked list. There we go. Paste that. Run the code. Okay, we should be nearing the end now. Just testing and then see if we can fix anything that went wrong. Okay, let's see. In here, we have 100 as the head because we pre-appended it to the list. So 1, 2, 3, and 3 is the tail. Okay, good. And after that, we remove 100 from the list. Okay, in here, it's now gone. Okay, that's good. So let's try to remove at the last index. So let's say doubly list dot length minus 1. Okay. Now I'll try to console.log doubly list. Of course, with console log an empty space as well, just to see it more clearly. Okay. Let's up some lines here. And here as well. Okay. There we go. Let's see how this goes. We should be removing 3 now. Okay, let's see. So the first one, we have our value to be 100, the first head, or the head to be 100, excuse me, and the tail to be 3. That's good, because in here, we appended 1, 2, 3, so 3 should be the tail, and then we pre-appended 100, so 100 should be the head. Okay, and in here, we removed 100, so the second console log, right here, 100 is gone. Okay, and the value is 1 and the tail is 3, or the head is 1 rather. And at the third console log, we remove the last item from this list. So in here we can see that the length is now 2 and the value or the value of the head is still 1 because over here is 1 since we removed 100, and then the tail's value is 2, which is, well, the second item in the list, or rather the previous node from the previous tail, which was 3, which is what was removed before. And now the new tail is equals to 2. Okay? And yeah, that's pretty much it. Wow. So I think we covered the edge cases now. So let's try to remove, so try to append 3 again. Then we will try to remove at 0th index. Let's see what that will look like. Okay? And then we'll just say remove last index or last item. And in here we can say removed item with value 100, and then down here you can say 1, 2, 3 space 1, 2, 3. There we go. Appended 3 and removed first item. Okay, let's try to run this now. Let's see the results. Okay, the first one, still the same, very good. Removed 100, okay. Remove the last item, so from 3, now we came to its previous node, which is 2, right here, very good. And now we appended 3, okay, and then remove the first item. So the first item on the previous one is 1, and then it points to 2. And down here, head is now equals to 2, which is very nice. And the tail, since we appended 3, is equals to 3. And it's pointing to 2. Okay. Okay, let's try to say here now, doubly list dot remove at 0 and doubly list dot remove at 0. Okay. Also log doubly list console log emptied list. Okay, so this should be emptying the list now because we only have 2 items at this point. Okay, let's see. Okay, nice. Whew. I should actually write some tests here in the future, but for now this is very nice. Okay. I'm satisfied with this. Okay, that's all. I hope you learned something and, probably watched me just hack at this because it's pretty fun and tiring at the same time. It's like you're thinking and explaining, which is fun. It reinforces what I know or what I've learned. And it's fun to see that I've actually got it to work. And debugged some edge cases that I did not notice. But yeah, the code will be available on GitHub, and right now we will commit. So created doubly linked list. And I hope you learned something. And thank you for watching. Good luck on your development journey and happy learning.